Welcome to Chemical Equilibrium, Lesson 5. The Le Chatelier Principle, Example 1. Table salt is added to the purple solution in equilibrium. So this reaction is in equilibrium. And then you have your disturbance. The disturbance is now table salt. Now they ask, use Le Chatelier's principle to predict the change in equilibrium position. Now first you need to figure out what the effect of table salt will be. What is table salt? Sodium chloride. That means in solution you will actually be adding sodium ions and chloride ions. In this reaction there is only chloride ions. If you add sodium chloride and you add effectively chloride ions, that means that the concentration of this chloride ion would then increase. So, the disturbance is the added sodium chloride. Remember that sodium chloride dissociate into sodium ions and chloride ions. The disturbance is then an increase in the concentration of the chloride ion. The disturbance is then an increase in the concentration of the product. Now if you go back to the previous lesson, I explained when you increase the concentration of the product, the reverse reaction would be favored. If you increase the concentration of the product, the reverse reaction would be favored. So all you have to know to solve this problem is this slide, this summary. If you know this part, you can answer the question. You just go to product is increased and then they tell you the reverse reaction is favored. So in this reaction, if you favor the reverse reaction, the color would change to blue because more of this blue molecule will be formed if you favor the rate of the reverse reaction. So then what would be observed? A blue reaction mixture. Example 2. For this reaction, delta H is 26 kilojoules. That means the forward reaction is endothermic. Now they ask you, what stress has occurred in the system? Let's look at the graph. Here is the rate of your forward reaction. Here is the rate of your reverse reaction. Here the rates are equal. And that is the definition of equilibrium. Your rates are equal. And here is your disturbance, disturbing your equilibrium. So what is the disturbance? An increase in the rate of both the forward and the reverse reactions. Can you see that both of the lines are increased? So now, if the rate of the forward and the reverse reactions are increased, it can only be caused by temperature or catalyst. A catalyst would increase the forward and the reverse reactions equally. That means both of the lines would end there at the top. But now the reverse reaction was not favored as much as the forward reaction. Temperature would favor the endothermic reaction more. And in the beginning of the problem, we noted that if you look at the reaction equation, delta H is positive. That means the forward reaction is endothermic. So, the endothermic reaction is influenced more. So therefore, what stress has occurred in this system? Temperature. Example 3. What is responsible for the change at T 10 minutes in the graph below? Here is your reaction rates. Here is equilibrium because the rates are equal, and now at 10 minutes there is a disturbance. And then equilibrium is reached again. So, what happened? An increase in the rate of both the forward and the reverse reactions. Both lines are increasing equally to form equilibrium again. Therefore, it can only be a temperature or catalyst that increases the reverse and the forward reaction. But in this case, they are increased equally because they are forming equilibrium straight after again. Therefore, the disturbance must be a catalyst. Otherwise, your graph would look like example 2. Last example. Consider the following chemical equilibrium and graph, and then you have to answer questions. This is your chemical reaction, and now you have a red line for CO, a blue line for Cl2, and a black line for CoCl2. So now they ask how much time was necessary for the system to reach equilibrium for the first time. When is the system at equilibrium? When the rate of the forward reaction is equal to the rate of the reverse reaction. That means the concentration of the reactants and the concentration of the product remains constant. So, at what time does these lines stay constant? After 15 seconds. You have equilibrium because the concentrations are constant. The second question. How do the rates of the reverse and forward reactions compare at the following times? Let's see. At T5, at this line, the concentration of CO is decreasing, the concentration of Cl2 is decreasing, and the concentration of CoCl2 is increasing. So which reaction would increase the concentration of CoCl2? The forward reaction. What reaction will decrease the concentrations of CO and Cl2? The forward reaction. So, the forward reaction is then faster than the reverse reaction. At T17, the concentrations is constant. Therefore, the rate of the forward reaction is constant to the rate of the reverse reaction. It's equal. There is no change. Then at time 23 seconds, the concentration of CO is decreasing, concentration of Cl2 is decreasing, and the concentration of CoCl2 is increasing. Therefore, the forward reaction must be favored. Now, the third question. Determine the equilibrium constants for the system at T17. So, the equilibrium constant can be written out as the concentration of the product to the power of 1 divided by the concentration of the reactants, both to the power of 1, because that is their stoichiometric value. Now, from the graph, you need to read off the concentration now at T17. So let's see, T17 is there, and there you read off your 3 concentrations. So the concentration of CoCl2, that is the black line, so that would be 0.75. The concentration of CO, which is the red line, would then be 1.75. The concentration of the Cl2 is the blue line, and that would be 0.6. So if you calculate Kc, you get to 0.71. And then question 4, what happens at t 20 seconds? At t 20 seconds, there is a disturbance in equilibrium. But what caused the disturbance? The concentration of CO is decreasing, concentration of Cl2 is decreasing, and the concentration of CoCl2 is increasing. That means the forward reaction is favored. So, if you favor the forward reaction, you have to add some reactant. Because there is a sharp peak in the CO graph, you can deduce that the concentration of the CO was increased to cause that peak there. And then the concentration of Cl2 will decrease slowly because it is now reacting to form more of the CoCl2, which is increasing, to reinstate equilibrium. Question 5. What effect does the stress at t 20 seconds have on Kc? Kc is only influenced by temperature. So if you add more reactants, there will be no effect on the equilibrium constant. Thank you.